In the vast expanse of space exploration, humanity has long dreamed of breaking free from our solar system's confines and venturing to distant stars. From the early days of rocketry to today's cutting-edge proposals, spaceship concepts have evolved into a fascinating blend of engineering prowess, scientific speculation, and sheer audacity. This tier list ranks some of the most intriguing ideas, from black hole-powered vessels to enormous solar sails, evaluating them on feasibility, innovation, and potential impact. Drawing from historical projects and modern theories, we'll dive into the best and most controversial aspects, highlighting how these concepts push the boundaries of what's possible while sparking debates on ethics, cost, and practicality. At the heart of this tier list is a celebration of human ingenuity. The best points shine through in the creative problem-solving. Instead of relying on traditional chemical rockets with their limited fuel and speed, these designs leverage physics in novel ways, like harvesting interstellar hydrogen or riding sunlight. They inspire awe by scaling up everyday concepts. Think sails not on oceans, but in the vacuum of space, or habitats mimicking Earth's gravity through rotation. Historically grounded, many stem from real initiatives such as British or NASA studies, adding legitimacy. Yet, controversies abound, particularly around nuclear elements that evoke Cold War fears, astronomical costs that could exacerbate global inequalities, and speculative tech that borders on science fiction, potentially misleading the public about near-term possibilities. Starting at the bottom with D tier, the Buzzard Ramjet. This idea, born from the minds behind Project Daedalus, proposes a spaceship that scoops up hydrogen atoms from space using a massive magnetic field, fusing them for propulsion. No need for bulky fuel tanks, just endless refueling from the cosmos. At its best, this embodies efficiency and sustainability, theoretically allowing near-light-speed travel without onboard resources. It's a nod to nature's economy, like a bird gliding on wind currents, and recent 2022 physics papers affirm its basic feasibility, reigniting interest in ramjet variants for deep space probes. However, the Buzzard Ramjet's controversies make it a rightful D-tier entry. The primary flaw is energy inefficiency. Capturing sparse interstellar hydrogen demands more power than the fusion yields, essentially creating a net loss. Early plans were scrapped for this reason, highlighting how theoretical elegance often crumbles under practical scrutiny. Scaling the magnetic field to the Earth-Sun distance is absurdly ambitious, raising questions about material limits and radiation exposure for crews. Ethically, pursuing such tech diverts funds from proven renewables on Earth, and critics argue it promotes a conquer-the-stars mindset that ignores planetary crises like climate change. Still, its inclusion in the tier list underscores a key strength, sparking dialogue on propulsion alternatives beyond fossil fuel analogs. Moving up to C tier, the O'Neill cylinder. Proposed by physicist Gerard O'Neill in 1976 and later endorsed by billionaire Jeff Bezos, this is a massive rotating habitat designed to simulate Earth's gravity through centrifugal force. Imagine a cylindrical tube, miles wide, housing cities, farms, and factories in space. Sunlight beams in via mirrors, solar panels provide energy, and materials launch from the moon using electromagnetic catapults, assembled by self-replicating robots. The appeal is profound. It's a blueprint for sustainable off-world living, potentially alleviating overpopulation and resource strains on Earth. With stronger materials like graphene, interiors could rival the size of countries like Cyprus or Switzerland, fostering self-sufficient colonies. This concept's best feature is its holistic vision, not just travel, but permanent settlement, blending ecology with engineering. Yet, the O'Neill cylinder is mired in controversy, earning its mid-low tier. Costs range from $900 million to $10 trillion per unit, necessitating pairs for stability astronomical sums that could fund global healthcare or education instead. Lunar mining raises environmental red flags. Disrupting the moon's surface might alter tides or contaminate space with debris. The reliance on unproven tech like self-replicating robots evokes sci-fi dystopias, where automation could lead to job loss or uncontrolled replication risks. Bezos's backing adds a layer of debate, as it ties space colonization to corporate interests, potentially creating elite enclaves while the masses stay grounded. Moreover, ethical quandaries arise. Who decides residency in these habitats? Could they exacerbate social divides with the wealthy fleeing Earth's problems? These low-tier concepts set the stage for the tier list's progression, illustrating a pattern, groundbreaking ideas tempered by real-world hurdles. They highlight the content's strength in balancing wonder with critique, encouraging readers to ponder not just how, but should we? As we ascend the tiers, the innovations grow bolder, but so do the stakes. As we climb the spaceship concept tier list, the ideas become more ambitious, blending proven physics with speculative leaps that could redefine humanity's reach into the cosmos. Mid-tier entries, particularly those in B tier, stand out for their elegance and potential realism, often drawing on natural forces like sunlight or theoretical phenomena like black holes. These concepts excel in minimizing fuel dependency, a perennial challenge in space travel, and inspire visions of sustainable exploration. The tier list's strength here lies in its ability to make abstract science relatable. Comparing sail sizes to states or countries helps demystify scales that boggle the mind. Moreover, by incorporating ongoing projects like NASA's solar sail missions, it bridges historical proposals with contemporary advancements, fostering a sense of progress. However, these mid-tier ideas are not without controversy. They often hinge on enormous scales or untested theories, prompting debates on resource allocation and environmental impacts. For instance, the sheer size required for effective propulsion raises questions about orbital debris or interference with astronomical observations. Ethically, pursuing such tech amid Earth's pressing issues like biodiversity loss or inequality can seem indulgent, especially when costs soar into the trillions. Critics also point to the militaristic origins of some space tech, fearing dual-use applications that could escalate global tensions. Yet, these debates enrich the tier list, turning it into a platform for thoughtful discourse on our cosmic ambitions. Leading the strong B tier is the solar sail, a concept that elegantly turns sunlight into propulsion, making it one of the most grounded yet revolutionary ideas on the list. Unlike traditional rockets that guzzle fuel, solar sails use the pressure of solar radiation photons bouncing off reflective surfaces to generate thrust in the frictionless void of space. This fuel-free approach is a highlight, promising indefinite acceleration over time. Currently, prototypes like NASA's Advanced Composite Solar Sail System are orbiting Earth, validating the tech for real-world applications such as adjusting satellite orbits or exploring the outer solar system. The tier list shines here by quantifying potential. A sail the size of Central Park might take 10,000 years to reach Alpha Centauri, our nearest star system, but scaling up to Texas-sized could slash that to 300 years. For crewed missions with 3 astronauts, it'd need to dwarf Africa, illustrating the trade-offs between speed and payload. The solar sail's appeal extends to hybrid innovations, like NASA's 2069 mission concept, which combines sails with ground-based high-energy lasers to boost speeds to 10% of light speed, arriving at Alpha Centauri in about 40 years. This laser-assisted variant addresses a key limitation, diminishing solar push farther from the sun by providing an artificial wind. Environmentally, it's a win. No emissions, no nuclear risks, just harnessing abundant stellar energy. This makes it a beacon for sustainable spacefaring, aligning with global shifts toward green tech. Enthusiasts argue it democratizes exploration, as smaller sails could enable swarms of affordable probes, expanding our knowledge of exoplanets without bankrupting nations. Controversies, however, temper the enthusiasm, landing it firmly in B tier rather than higher. The glacial timelines for unassisted sails raise bioethical concerns. Multi-generational voyages imply ethical dilemmas around reproduction in space, radiation exposure, and psychological strain from isolation. Larger sails pose logistical nightmares manufacturing and deploying something. Texas-sized would require unprecedented orbital infrastructure, potentially cluttering space with debris and complicating satellite operations. NASA's laser proposal adds another layer. High-powered beams could be weaponized, echoing fears from the Star Wars defense initiative of the 1980s. Moreover, funding such projects diverts resources from immediate needs, like climate adaptation or poverty alleviation. Critics, including some astronomers, worry about light pollution from massive sails obscuring telescopes, hindering studies of the universe they aim to explore. Transitioning to another B-tier standout, the Black Hole Starship. This audacious proposal involves creating a microscopic black hole aboard the ship, fed with waste matter to generate Hawking radiation as fuel. Theoretically, it offers 100% energy efficiency, propelling vessels to 10 to 90% light speed and making interstellar jaunts feasible in decades rather than millennia. Interplanetary trips within our solar system could shrink to days or weeks, and a single black hole might power entire fleets. The concept's brilliance lies in solving multiple problems at once: propulsion, waste management, and energy scarcity, all via quantum gravity principles. It's a testament to theoretical physics power, drawing from Stephen Hawking's work and inspiring discussions on unifying general relativity with quantum mechanics. Yet, the Black Hole Starship is profoundly controversial, blending cutting-edge speculation with near impossibility. A recent study, No Black Holes from Light, concludes it's unfeasible without idealized conditions, as creating such singularities demands energies beyond current colliders like the LHC. Safety risks are paramount. A mishandled black hole could evaporate explosively or, in worst-case scenarios, grow uncontrollably, though physics suggests micro-black holes evaporate harmlessly. Ethically, experimenting with such forces evokes Frankensteinian hubris. Tampering with space-time could have unforeseen cosmic consequences. Resource-wise, the tech requires advancements in particle physics that might better serve fusion energy on Earth. Proponents counter that breakthroughs often stem from bold ideas, but detractors see it as distracting from viable alternatives like antimatter drives. These B-tier concepts elevate the tier list by showcasing scalable, innovative propulsion, yet they underscore the content's balanced critique, wonder tempered by realism. As we approach the high tiers, the nuclear elements intensify, promising greater power but heightening risks. As the final echoes of these spaceship concepts fade into the infinite blackness of space, we stand at the precipice of destiny, hearts pounding with the thunder of possibility and peril. This tier list is no mere catalog of dreams. It's a siren call from the cosmos itself, a dramatic saga where human ingenuity clashes with the unforgiving laws of the universe. From the humble Buzzard Ramjet's futile grasp at interstellar hydrogen to the colossal Super Orion's nuclear roar, we've traversed a landscape of innovation that could either crown us as galactic wanderers or condemn us to eternal regret. Imagine vessels slicing through the void at fractions of light speed, black holes humming like captive gods in engine cores, sails unfurling like the wings of ancient myths across the heavens. These are not just blueprints. They are the beating pulse of our species' unquenchable thirst for the beyond. Yet, in this grand theater of exploration, drama unfolds not in triumph alone, but in the shadows of controversy that loom like dark nebulae. Picture the Medusa Drive's parachute, billowing against the shockwave of a Hiroshima-sized blast efficient. Yes, but at what cost? Radiation ghosts haunting orbital paths, treaties shattered like fragile glass, and the ethical abyss of weaponizing the stars. Or the O'Neill cylinder, a rotating Eden promising salvation from Earth's woes, yet demanding trillions in tribute, lunar scars from electromagnetic catapults, and the hubris of self-replicating machines that could spiral into nightmare. Solar sails whisper of purity, riding sunlight's gentle push, but demand scales vaster than continents, raising specters of orbital clutter and generational exile on voyages spanning centuries. And the Black Hole Starship? A Promethean fire stolen from quantum realms, offering godlike efficiency, only to be dashed by physics' stern decree. Impossible without miracles we may never conjure. This tension is the heartbeat of our cosmic drama, a high-stakes gamble where the stakes are nothing less than our survival. We've seen the best, analogies that shrink the unimaginable to the palm of your hand, like comparing a starship's girth to statues of liberty stacked tall, or sails rivaling Texas in sprawl. Historical threads weave through, from 1960s mad geniuses like Philip Bono, crafting Mars gliders amid Cold War frenzy, to modern endorsements by visionaries like Bezos and Sagan, who dared repurpose nuclear arsenals for peace among the stars. These elements educate and ignite, turning abstract theories into vivid tapestries that inspire the next generation of engineers, dreamers, and explorers. They remind us that space is not a void to conquer, but a canvas for our boldest strokes. But the controversies? They roar like supernovas, demanding we confront the darkness within. Nuclear propulsion's allure masks a Pandora's box of proliferation risks, where today's starship could become tomorrow's doomsday weapon. Military undercurrents in Bono's designs echo modern fears of space as a new battlefield, with space forces circling like vultures. Economic chasms widen. Who funds these trillion-dollar fantasies while billions hunger on a warming planet? Environmental tolls mount lunar mining ravaging our celestial neighbor, debris fields choking the skies, and ethically? The human cost of isolation, radiation, and unborn generations conscripted to starbound arcs weighs heavy, a moral quagmire that could fracture societies. In this climactic moment, as we teeter on the edge of a new space renaissance, with NASA's lasers poised in private titans like SpaceX charging, ahead the tier list issues a thunderous ultimatum: pursue with wisdom or perish in folly. Let these concepts not just propel engines, but forge an enlightened path. Harness the fire of innovation, but temper it with humility. Safeguard our blue marble while reaching for the stars. For in the grand opera of the universe, humanity's role hangs in the balance. Will we ascend as enlightened voyagers uniting in triumph over the unknown? Or succumb to hubris, our ambitions crumbling like forgotten ruins on a distant world? The stars await our answer, dramatic, decisive, and defining. Choose wisely, for the cosmos is watching, and the final act is ours to write.